Here's a deceptively elegant exponential equation. 2 to the power of x plus 2 equals 8 to the power of x minus 1. The solution, it's hiding in plain sight. Let's find it. Quick reminder, if a to the power m equals a to the power n, then m must equal n. This works because exponential functions are one-to-one. Starting equation. Notice that 8 is 2 cubed. 8 equals 2 to the third. Let's substitute. Replace 8 with 2 cubed. Power rule. Multiply the exponents. Same base achieved. 2 to the x plus 2 equals 2 to the 3 times x minus 1. Same base of 2 on both sides. Therefore, x plus 2 must equal 3 times x minus 1. Drop the base. Now we solve the linear equation. X plus 2 equals 3 times x's minus 1. Expand the right side. X plus 2 equals 3x minus 3. Collect x terms on one side, constants on the other. Negative 2x equals negative 5. Divide both sides by negative 2. X equals 5 halves. That's our answer. Setting up our coordinate system. Blue is 2 to the x plus 2. Green is 8 to the x minus 1. Both grow exponentially. They intersect at exactly x equals 5 halves. Perfect match. This intersection point confirms our algebraic solution. Let's verify by plugging 5 halves back into the original equation. Left side, 2 to the 9 halves equals 16 root 2. Right side, 8 to the 3 halves also equals 16 root 2. Perfect match. Solution verified. X equals 5 halves. Found algebraically, confirmed graphically, verified completely. The power of the same base principle. If you enjoyed this, hit like and subscribe for more mathematical problem solving. Until next time.